Center of Mass: How It Affects Snowboarders and Skiers by Andrew Lee, Ty Allen, and Jordan Winter. So contemporary snowboarding and skiing was introduced in the late 1990s. These events included slopestyle, superpipe, moguls, and most of the freestyle events that we see today that can be found in the X Games, Olympics, and various other competitions throughout the country and around the world. For a rider to be successful, there are multiple things that they need to pay attention to, including balance, maintaining speed, and one that some people find most importantly as center of mass. So several of our group members have backgrounds in snowboarding and skiing, and we wanted to find out how to ride more efficiently through a change in center of mass. So our purpose of our experiment is to determine if by changing the center of mass mid-ride, how would the speed of the rider change? So we wanted to find a correlation between a rider's center of mass and their speed and their distance covered. So this is really important to skiers in real life because the difference between first place and not medaling can usually be within seconds. And we want to determine if those seconds could be made up by an efficient use of a person's center of mass. So we constructed a ramp out of reclaimed wood that measured 34.5 inches long on the hypotenuse, and it was 5.5 inches tall. So this put the ramp at an angle of elevation about 9.17 degrees. So we took multiple recordings of a 9-volt battery on top of a tech deck or a miniature skateboard at two different positions. So one where the 9-volt was laying horizontally and one where the 9-volt was vertical. So then we tracked each of the tech decks over time using a video analysis software program called Tracker to determine position and velocity equations. So as we can see here, this is the first test where we have the 9-volt battery laying down horizontally on the board. And as you can see, it moves rather quickly down the slope. In the next video, we can see where the battery is vertical on the ramp. And there's a noticeable difference that the battery is much slower going down compared to when it was horizontal on the board. Shown here, we have two graphs of the laying down rider on the left and the rider standing up on the right. So as you can see with the graph on the left, the slope of the parabola shape is much steeper than the slope on the right. So this really shows that the velocity is faster, in fact, for the rider that is laying down compared to the rider that is standing up. And these videos were, or these data points were found using Tracker. This is what, through video analysis and the program that Tracker allowed or provided, we were able to find these data values. So in conclusion, we were able to determine that a lower center of mass actually does prove that there's a higher velocity. So there are more factors other than just conservation of energy that play into a rider's success. So these can also have, due to friction between the board and the ground, and air resistance, which are typically negligible. We found that there could be multiple places for error within our presentation, within our project, such as human error, possible throughout this entire experiment. But we also tried to limit this by keeping many of the same variables constant. So we sent each board down on the same slope, and we really tried to make those constant. Thank you for listening.